In this video, I am reviewing the answers for review exam number 4. We begin number 1 with a problem that involves computing the confidence interval for the mean. And we are given the population standard deviation. Thus, we will use z-values in this computation. So all of the information is given. 40 is n, 186 is the sample mean, and the population standard deviation, which is known as sigma, is 6. We have to find our z-value. To do that, we will go to table F, look at confidence intervals, and we look for 95%, go all the way down to the z-values to get 1.96. So once we plug everything into the formula, we perform our computation. I'll go ahead and just work out these values using a calculator. So we have 186 minus 1.96 times 6 divided by radical 40. We hit enter. We get 184.14. In the problem, they want us to round to a whole number, so we just rounded to 184. Now, instead of having to retype all that information, we can simply, using this calculator, select the equation, hit enter, and then we could change the minus to a plus, and that's going to get us the right endpoint, 187.85, but we're rounding to a whole number, so it rounds to 188. Number 2, we have, once again, it's a confidence interval for the mean, but this time we're given the standard deviation of the sample. So that means we're using t-values instead of z-values. So instead of using a z-value, we use a t-value. Instead of using sigma, we use the sample standard deviation, s. To find the t-value, we have to compute degrees of freedom, n minus 1, so 20 minus 1 is 19, and then we look it up in table F, 90%. So we go to 90%, go all the way down to 19, and that's 1.729. And that's what we plug in. So the sample mean is 8.6, t is 1.729, sample standard deviation is 1.6, n is 20, and we can calculate this confidence interval using a similar method to what we used in number 1. And it turns out that the mean is estimated to be between 8 and 9.2. Number 3, we're computing a confidence interval for proportions. So the first step is to compute the sample proportion. That's going to be 360 out of 600, which is 0.6. We also need q hat. This is called p hat and this is called q hat. It's 1 minus 0.6, and that's 0.4. And whenever we work with proportions, we always use the normal distribution. So thus, we look up 95% in our table like we did previously. The z-value is 1.96. And so we're going to plug all this information into our formula. P hat is 0.6, z is 1.96, radical p hat is 0.6, q hat is 0.4, n is 600. And then let me go ahead and just use the calculator to type in that information. So we have 0.561 minus 1.96 times the square root of 0.6 times 0.4 divided by 600. Hit enter, and we get 0.521. I think the error is I typed in 0.56 when it should be 0.6. So let's go back and correct that. Let me go back and edit that really quick. So we'll hit delete, and then we'll hit delete over here. So be really careful when you type in your values. It should be 0.6. That's our p-hat. And then we get 0.5608. That's going to be 0.561. That's the value we wanted to calculate. And then once again, we can come back and we can edit the equation and then just change the minus to a plus. .639 is the right endpoint. Number 4, we're estimating the sample size for proportions. In this case, we're actually given p-hat, it's 0.6. So if p-hat is 0.6, 1 minus p-hat is 0.4. We have to find our z-value. So once again, we use our table. Let's just look through it one more time. So for 98%, we go all the way down to the z-value, 2.33. And then the error is 0.03. So that goes in there. We perform the computation. We get 1,447.706. Always round up to 1,448. Number 5, it's a similar question, but now it's for a mean. So this is our formula that we use. The z-value, once again, we can look this up in table F. 2.58. Standard deviation is population standard deviation 0.04. The error is 0.01. Perform the computation. Round the final answer upwards to 107. Let's take a look at number 6. Number 6 says the following. There's a school that's claiming that the students will average 80 words per minute in diction. That's going to be the claim. The claim is that the mean is equal to 80. That's H naught because it has equal. H sub 1 has to be the mean is not equal to 80. This is a z-test because we're given the population standard deviation. And so we draw a normal distribution. We will look up, it's two tails because we have a not equal to, and we need to look up the critical values in table F. So it's a z-test, two tails, alpha's 0.01. Two tails, 0.01 go all the way down, 2.58. Those are the two critical values. One will be positive, the other will be negative. Next, we have to calculate our test point. So x bar, the sample mean is 88, population mean is 80, standard deviation is 18, and we divide that by the square root of 30. Let's calculate that using our calculator. So we use parentheses, 88 minus 80, close the parentheses, divided by, I like to use parentheses again for the standard error. That's 18 divided by the square root of 30. Close the parentheses, and then we hit enter. And we end up with our value, which we need to convert. Let's go to our mode. We want to convert this to classic. So now let's go back to our problem. Let's retype it in again. That way we make sure we get a numerical value rather than a math print value. So 88 minus 80 divided by parentheses 18, that's divided by the square root of 30. Hit enter and we get 2.43. Now 2.43 does not fall in the critical region, it falls in the non-critical region, so we say do not reject H naught, and then we have to summarize. So we come back to our claim. Our claim is H naught, and there is a summary chart that we can use to help guide us. The claim is H naught, we do not reject H naught, we say there is not enough evidence to reject the claim. That's our summary. There is not enough evidence to reject the claim. Now, number 7, we have another hypothesis test, but now we're asked to find the p-value. Okay, and in this case, it is a z-test because we're given the population standard deviation. And so the claim is this, is that the light bulb, it's a manufacturer who claims that his light bulbs have a mean life less than 1150. So the mean is less than 1150. That's the claim. That's H sub 1. H naught is always, the mean is 1150. We calculate Z using the same formula. This is our test point formula. Sample mean is 1135 minus the population mean is 1150 divided by 80 over radical 144. That's going to give us negative 2.25. So when finding the p-value, we first have to compute the standard error, so negative 2.25. We then have to look up this tail area. So we will go to table E to look up the tail area for negative 2.25. So negative 2.25 is 0.0122. So that's this area. Since it's a one-tail test, that's our p-value. The p-value is 0.0122. It's less than alpha. Alpha is 0.05, so we reject H naught. And then let's look at the summary chart to review how we summarize. In this case, the claim is H1, and we rejected H naught, so we put there is enough evidence to support the claim. So number 8, once again, we're testing a mean, but this time we're given a sample standard deviation. So that means we're applying the t-test. And the claim is that the mean is 95. So the mean is 95, that's our claim. It's H naught. H sub 1 has to be the opposite statement. The mean is not 25. Once again, we calculate t using our calculator. The formula is basically the same. The only alterations is we have a t value and sigma is now s. And just calculate as I showed you before on the calculator in a similar manner. The t value is 1.92. Since we have the mean is not equal to, it's a two-tailed t-test. To find the critical values, we look up degrees of freedom. N minus 1, 20 minus 1 is 19, so it's two-tailed. Alpha is 0.05. Go to table F. Two tails, 0.05, go down to 19, 2.093. And since it's two tails, we have a positive 2.093, a negative 2.093. The test point falls in the non-critical region, so do not reject H naught. And let's use the flowchart again. The claim was H naught. We did not reject, so there's not enough evidence to reject the claim. That's how we write out the summary. Number 9, we're testing for proportions. The claim is that there's an industry benchmark of 50%. And the claim is that the Foothill Hospital exceeds that benchmark. So P is greater than 50%. That's the claim. It's H1. H0 is P is equal to 50%. Well, for this problem, this is our test point formula. We need to calculate P hat. So P hat is 31 over 50.62. P is 50% or 0.5, and Q is 1 minus 0.5, which is 0.5. We would plug this into the formula and calculate. Let's use our calculator to perform that computation. So we have 0.62 minus 0.5 divided by the square root of 0.5 times 0.5 divided by 50. Hit enter. We get 1.697, which rounds to 1.7. And since it's a right-tail test, and we always use the z-test when testing for proportions, we look up our critical value for one tail 0.05 to get 1.65. The test point does fall in the critical region, so we reject H0. We can use our summary chart to determine that there is enough evidence to support the claim. Number 10, we're testing the difference between two means, and we know we're using the z-test because we're given two population standard deviations, and the claim is that the average home price in the northwestern part of the city is greater than the average home price in the southwestern part of the city. So our claim is mu sub 1 is greater than mu sub 2. That's H sub 1. H0 has to be that the two means are equal. So once again, it's a right-tailed test because it's greater than. We look up our critical value in table F. It's 1.65. When we calculate our test point, this is the formula we use. Keep in mind that mu1 minus mu2, since we're assuming they're equal, that's going to be 0. So I just kind of don't write that down in the calculation. Let's go ahead and perform this computation. Let's type it in. So in the numerator, we have 948,520 minus 855,640 divided by, let's write down our square root. And then we take 95,250 squared divided by 30 plus 82,387 squared divided by 45. Hit enter. We get 4.36. That's going to fall in the critical region. We reject H0 using the summary chart. We see that there is enough evidence to support the claim. Number 11, once again, we're testing the difference between two means, but now we're given sample standard deviations. So we're using a t-test. The claim is that there's a difference in the prices of domestic and imported wine. So that means that mu1 is not equal to mu2. That's our claim. That's H sub 1. H0 is that the two means are equal. The formula is somewhat similar to the previous formula for number 10, except that we have T and the sigmas are now S's. Same thing with mu1 minus mu2, they're 0. So we put down the difference between the two sample means, the square root of each sample standard deviation squared divided by the sample size. Once again, we could just key in this information like we did in the previous example to get, and the answer is -2. Now, this is a two-tailed test, right, because it's not equal. To find the critical values, we have to compute n1 minus 1. So 15 minus 1 is 14. And n2 minus 1, 10 minus 1 is 9. But we picked the smaller of these two values to be degrees of freedom. 9 is smaller, so the degrees of freedom is 9. And then we look up our critical value. So it's two-tailed 0.05. And then go down 9, 2.262. So that's how we get negative 2.262, positive 2.262. The test point is negative 2. That's going to fall short of the critical regions. So do not reject H naught. And then let's just look at the formula or summary chart. The claim is H1. We didn't reject H naught, so we write down there is an we do not reject H naught. We put there is not enough evidence to support the claim. And then for number 12, we're testing the difference between two proportions. And in this case, we're stating that the percentage of Democrats who favor a tax increase is greater than the percentage of Republicans who favor the increase. So that's P sub 1 is greater than P sub 2. That's our claim. H naught would be P sub 1 is equal to P sub 2. Step 1, we have to compute sample proportion 1. That's 140 out of 200, 0.7. We compute sample proportion 2. That's 90 out of 150, 0.6. We have to compute P bar, so we add the two X values together. 140 and 90 is 230, divided by the sum of the two sample sizes. 200 and 150 is 350. That's going to be 0.657. We compute Q bar. That's 1 minus 0.657, 0.343. We're now ready to calculate the Z value. It's the difference in the sample proportions divided by the square root of P bar Q bar times 1 over N1 plus 1 over N2. Let's go ahead and calculate this value. So we have 0.7 minus 1.6 divided by the square root of 0.657 times 0.343 times, and then we put a parentheses inside the radical. 1 divided by 200 plus 1 divided by 150. We close the parentheses inside the radical and then close the parentheses outside of it, hit enter, and let's see. Let me go back and recheck that again one more time. Parentheses 0.7 minus 1.6 divided by the square root, we have 0.657 times 0.343 times parentheses 1 over 200 plus 1 over 150. Enter. And so we're getting negative 17.56. And so I will have to double check that one more time. Oh, I see what the issue is. The issue is, let me correct this here. There's a typo in this problem here. I have to correct it. And the typo is that 1.6 was typed in. It should be 0.6. Sorry about that. Let's go ahead and let's recalculate this value. So let me just edit this here. And let's go back and change 1.6 to 0.6. So you always have to be really careful, and then we get our result 1.95. Yeah, so just be very cautious when you type in your formulas or write them out. So we get 1.95, that's going to fall short. We can look up the critical value in table F using z-values. Do not reject H0. There is not enough evidence to support the claim. Thanks for watching this video.